that. So we bring our columns down, 0.420 minus x, x, and x. And then we know what happens next. I'm going to put that into the expression for the Kb, which is, the Ka. This is behaving like an acid, so this should be a Ka. So H3O plus times B divided by the BH plus, okay, and that's equal to x times x over 0.420 minus x. Okay, now I'm glad I made that mistake actually in the beginning, because this is an ionization constant for an acid. But I'm not given an ionization constant for an acid. I'm given what the ionization constant is for the base. The Kb is 1.7 times 10 to the minus 9. So I need to use that to calculate the Ka. And it comes about from this relationship. The Kw is equal to the Kb times the Ka. So I can rearrange it and then say the Ka is equal to the Kw, which is given. It's 1 times 10 to the minus 14 over this Kb. Okay? And so let me draw a line here so I don't get things mixed up too much. So that Ka is going to be equal to 1 times 10 to the minus 14th divided by 1.7 times 10 to the minus 9. Right? And that turns out to be, if you do the math, 5.88 times 10 to the minus 6. Okay? So now I'm going to use that here. So all of this is equal to that Ka, 5.88 times 10 to the minus 6. Okay? Well, once again, what you're going to do is you're going to solve for x. Okay? And this is one where we can use, I expect that x is going to be really small, and my Ka times 100 is still less than my initial concentration, so I can do the approximation method. Just approximate that, and that goes away. So it becomes x squared over 0.420 equals 5.88 times 10 to the minus 6. Okay? And now I can just solve for x by multiplying both sides by 0.420 times 0.420, so they cancel over here. Okay? And then the other thing I'm going to do is I'm going to take the square root of each side. So then I get an answer for x. X will be equal to 1.57 times 10 to the minus 3. Okay, now what is x? That is, if you look at your table up here, x is equal to the equilibrium hydronium ion concentration. So that's a molarity. It's equal to the H3O plus concentration. Okay, we'll go back up to the question. It says, what is the pH? Okay, well, that's good that I have the hydronium ion concentration, because I know that the pH is equal to the negative log of the hydronium ion concentration. Okay, so it's equal to the negative log of 1.57 times 10 to the minus 3. And that turns out to be 2.8. And that's your answer.